Good evening, everyone. Today I'd like to talk about a project involving nested petrolets. Next page, thank you. The progress includes three main goals. First of all, what's a nested petrolet? A petrolet is a graphical tool used for modeling and analyzing system. It consists of places, transitions, and arcs, and can represent complex behaviors such as current process and resource sharing. Um, a listed petrolet is an extension of a petrolet, where a petrolet can be embedded within a place of other petrolets. Um, this allows for modeling of systems with hierarchical structures and multiply levels of abstraction. Now on to the project goals. Next page, thank you. The first goal is initialization of listed petrolets. This involves creating a user-friendly interface that can display a listed petrolet and its hierarchy in a clear way. The interface should allow users to easily navigate through the different levels of abstraction and view the underlying structure of the model. The second goal is import-export of a listed petrolet, which means developing in a mechanism for importing nested petrolets from other tools or formats, as well as exporting the model to be used in other software. Finally, the third goal is simulation of a listed petrolet with probabilities and times. This involves creating a simulation engine that can handle the probabilitical nature of nested petrolets, as well as incorporating timing constraints to represent real world system. Thank you for listening. I finished my part. The next part belongs to Zhonghui. Thank you.
We have 2 points about the existing modeling problems, such as these photos. Complex systems always make people confused. So the first problem is modeling and analyzing complex systems. For example, climate change system. There are numerous unrelated factors that affecting system analysis. The second aspect is that of multi-level structural system involving interactions and influences between levels. For example, the study of organizational management system. There are interactions and dependencies between these levels. Without NP-net models, the modeling and analysis may require the other cumbersome methods, especially in multi-agent distributed systems. It could use to solve difficult problems. NP-net is a special type of PetriNet because NP-net are an extension of PetriNet. They contain other PetriNet at their own places and transitions. It is modeled for hierarchical multi-agent systems. There are 3 parts about the importance about NP-net models. The first is less coupling between models. For either a refactoring and extension, NP-net also supports the concurrent exclusion of multi-models. It has autonomous behavior, which can improve the efficiency and performances of the system. It also supports the modeling of multi-levels and the establishment of connections. This model can either or to modify. In addition, it is used to describe the interactions and dependencies between multi-subsystems. For example, when PetriNet A have to triggered by PetriNet B, NPNet can describe this relationship very well. Last but not least, NP-NAT can copy its own as their element, have their own structure and behavior, and their number is infinite. Let's turn to Xiaoyi. Thank you.
Well, Zhonghui just talked about the importance of the project, and I would like to talk about the timing of the project. We plan to have 4 steps of the project. The first one is the visualization of a nested Petri net, and we would like to use some libraries like Graphics or Matplotlib. And this will take about 2 weeks, and we plan to finish this part during week 5 to week 6. And the second part is the import or export of a nested Petri net. This will take another 2 weeks, and we plan to complete this part from week 7 to week 8. The next part is a simulation or a nested Petri net with probabilities and times. We would like to use some libraries like PetriNet Simulator or PetriNet Simulator, and we plan to finish this part in another 2 weeks, from week 9 to week 10. And the last part is the testing and modification part. We would like to test the model and see if there are any errors. And this part will be completed within 2 weeks. And we plan to finish this during week 11 to week 12. In conclusion, we can finish the project within 12 weeks and hand in the project within this semester. Well, I have finished my part, and the next part belongs to Qiu.
Let me introduce you to some exciting development in the really technical thing that is extension to the PeriNet, which makes it nested PeriNets. The extension builds upon the traditional PeriNet model, adds new layers of complexity, making it more suitable for real-world applications. Nested PeriNet extension involves some of the multiple PeriNets that can be nested within one another. This allows for you to model the complex systems with multiple layers of abstraction. The nets can communicate with one another, which allows the transfer of vital information and the coordination of actions between different levels of the system. One key advantage of the extension is it enables the ability to model large-scale systems. For example, you can have it to model complex manufacturing process, and by doing that, you have multiple layers of abstraction. By breaking down these systems into smaller, more manageable building blocks or units, it becomes much easier for the manager to analyze and do any kind of optimization. Another important thing is that nested PeriNets is a field of software engineering, which our team will be mainly focusing on. Here, it can be used to model complex systems, and we will be able to understand some of the typical behavior, and based on that, we are looking forward to build a platform, a really useful tool, a very powerful editor. It's really one shoe for all. And the sophisticated framework is easy for the user friendly. So if you have any questions, you can reach out to me. Never hesitate to email me. Thank you.